Hello all. Once again, a warm welcome to SPS Physics classes by S. Panindra Sharma. Today, let us try to deal with one of the first important concept in the rotatory motion, that is about movement of inertia of the system. Okay, let us see some important concepts in the movement of inertia of the particular case. The first point is nothing but movement of inertia of the single particle system is always given by I is equal to mr square, where this is the rotation axis, like AB is nothing but rotation axis and m is nothing but mass and r is nothing but perpendicular distance from the axis of rotation. Suppose in the given problem our point charge object is given with some angle alpha degrees is given here, then in such a case perpendicular distance will be, this is called as perpendicular distance or perpendicular distance. So this perpendicular distance has to be taken care in calculation of moment of inertia of the single object. Second case, suppose some system of particles are given. System of particles, particles means individual masses are given. Under such a condition, we have to take care I is equal to sigma mi ri square, which is called as sigma of I. So like this we can write down. In this particular case, movement of inertia, further you can consider this one as what? A tensor quantity. Movement of inertia is nothing but a tensor quantity. It depends on axis to axis. Please remember, very important. Now, third one is after completion of this, when you know the radius of gyration of the material, we can apply I is equal to simply mk square, where k is known as radius of gyration. So to determine the k value in the examination, there may be a type of question. So I value is equal to sigma ii by sigma mi is the first formula, and second formula is nothing but I1 plus I2 plus dash 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 In divided by M1 plus M2 plus dash dash dash, you can write down as Mn. Now in the given case, if all masses are same in the moment of inertia calculation, then the value of k becomes r1 square plus r2 square plus dash 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 rn square by n, we can write down. This is the formula for utilization of radius of gyration based question. And fourth one is nothing but in the examination, suppose integration problem is there, then you can write down as r square into dm. So we have to substitute limits and then we have to find out the value of total moment of inertia of the system. Now let us consider one important note. In the entrance examination, these kind of questions will come. Very interesting. Number one. So this particular moment of inertia of the system depends on what factors? So moment of inertia depends on number one, or depends on a point number A, mass, number B, distance from axis of rotation, point C, rotation axis, point D, mass distribution. So it depends on the four important factors, and it is independent of what factors? So independent of what factors? Independent of only one parameter, that is called angular velocity. Angular velocity. That means in this particular case, if the object is rotating along in this direction with omega, or rotating with 2 omega, or maybe in this direction with omega by 2, okay, you can imagine any one of the situation, angular omega represents angular velocity, any one of the angular velocity we can take, but independent of angular velocity. Whatever the angular velocity of the object, okay, moment of inertia has to be always computed using the fundamental formulas like this. And further, we can calculate with another important thing, error calculation. Delta I by I into 100%, this is given by simply 2 into, we can write down as a delta R by R into 100%, we can write down, which is equal to 2 into. What is delta R by R? Delta R by R means a change in length by original length, which is given by alpha into delta T from the thermometry chapter. Later we have the discussion. So let us substitute in this particular case. Therefore 2 into alpha into delta T we can write down, where alpha is called as a coefficient of linear expansion of materials and delta is nothing but temperature change. So by using this formula, one can determine percentage increment or decrement of moment of inertia in the system. And third, now by using sometimes in the examination, sometimes it is necessary to use parallel axis theorem and as well as perpendicular axis theorem. Therefore, the third point is nothing but we know that Ix is equal to Iy plus Iz. Similarly, fourth one is nothing but I is equal to I naught into can write as what and d square we can write down. So the third one belongs to perpendicular axis theorem and fourth one belongs to parallel axis theorem. So any one of the formula based question for conversion of systems will be given to us in the examination. Okay. Next, fifth important point is nothing but you can write down as kx square is equal to ky square plus kz square, and sixth important formula is nothing but k square is equal to k naught square plus d square. We can write down further continuation of the remaining formula. Anyways, by applying these particular formulas for the entrance examination point of view, definitely we will win in the exam. The moment of inertia of individually regular shaped objects one by one. The first one, that is a moment of inertia of a circular ring. An axis passing through center of mass contains a moment of inertia of mr square. Next one is a circular disc about its natural axis mr square by 2. Next, hollow sphere about its natural axis 2 by 3 mr square. And finally, solid sphere about natural axis 2 by 5 mr square. And a rectangular lamina about natural axis m by 2 of L square plus B square. And for rod, here we are seeing for rod about center of mass it is ml square by 12 and perpendicular to length about one edge it is ml square by 3. So these are the standard shapes and standard calculations for moment of inertia. Thank you.